Hello, and welcome to our podcast where we discuss topics around the commercial vehicle or work truck industry. Those things that are applicable to each and every one of you tuning in today, I hope. I'm Steve Henning, your host, and as always, thanks for joining us. Today, we've got a special treat. We're going to talk about some really interesting topics, and I'm joined by Josh Anderson, the CTO at Workhorse. Josh, hello, thanks for joining us.
Hey, Steve, great to talk to you today.
Well, we appreciate it. And for those, I guess, in our audience that maybe are not familiar with Workhorse, if you could spend just a minute telling us what Workhorse is all about and maybe even shed a little light on how you became the CTO there.
Sure. So, Steve, for those not familiar with Workhorse, Workhorse is an electric last mile delivery truck and chassis manufacturer. Workhorse has a long and varied history. The current company's been around about 10 years. But the history of the company goes back almost 100 years, building mostly last mile step vans on various chassis and then producing their own chassis for the last couple of decades.
I did not realize there was a 100-year history there. That is very interesting. Thanks for sharing that.
Absolutely. I came to the company about 3 years ago because we needed to develop a brand new product and kind of relaunch as a full OEM.
Okay.
Workhorse had become more of an R&D company that was doing new advanced technology, but we really wanted to make the company an OEM that could produce in volume a steady, reliable product for the market.
That makes sense. Okay. I was going to comment, you didn't look like you were anywhere near 100, so I was pretty sure you hadn't been there that long.
I don't know. The white hair shows up quickly.
Well, I have the same issue, so I understand. Okay. Well, that's great. Thanks so much for the history on that. Let's go ahead and just dive into our topic a bit. So, I think anybody that pays attention to any sort of media, from, watching what's online to reading, et cetera, there's all kinds of talk about EVs and hybrids and comparisons to ICE vehicles. I suspect there's probably also a bit of at least misunderstanding, particularly about use case, range, those kind of things. So let's jump into that just a little bit. And in prepping for this, doing a little research on my own, I know there's some interesting things that Workhorse is doing around the regenerative braking arena. So maybe you can, I guess, start with that. Just tell us a little bit about regenerative braking and how it differs from what we would consider traditional braking systems.
Sure. So, Steve, whether it's your car or a traditional internal combustion truck or anything else, you're probably used to filling your gas tank with fuel, diesel, gasoline, something like that, and then burning that in an engine. So you're taking this stored fuel and you're turning it into the energy that moves the wheels, that rotates the wheels, right? Battery electric trucks are really no different, but we're storing energy in a battery, and we're using that to turn an electric motor. And once it leaves the electric motor, it's doing the same thing. It's turning the wheels. I like to use the example of those little spring-loaded cars you used to get when you were a kid. Remember, you pull them back and you load them up, or you wind them up, and then boom, they go forward, right?
Right.
So that spring in there is just like your fuel tank or your battery. If we're playing with this car here and we get it going, to stop it, we have to grab the wheel, or with our finger, or putting it on a surface, and that acts just like a brake. So we put some drag on it, and that slows it down so we can stop. And, that's what you're doing when you put your foot on the brake pedal when you come to a stop sign.
Makes sense.
Right. So far, pretty simple, right?
I agree.
We got to do the same thing, whether it's internal combustion or electric. But the spring is a good analogy for what we can do with regenerative braking. So you can't, to recharge one of these springs, you wind the car back a little bit. You turn the wheels backwards. Well, with a gas car, you can't do that and put gasoline back in your tank. But with a regenerative braking, you can turn the electric motor a little bit backwards, and that'll put a little bit of juice back into that spring. So now you've got a little bit more oomph for next time you go. This doesn't mean it doesn't mean that the car is going to go backwards on you, but you start to turn that motor backwards against the car, and as you coast down, you use that drag from the motor trying to go backwards to push electricity back into the battery. And you get the added benefit of control. You get to slow the vehicle down at the same time. So you
Okay.
kind of get two for one.
That's a great way to explain it. I really like the visual aid too. I have young granddaughters, so they would certainly appreciate that. So that's a
Yeah,
really
even
good
at my
way.
age, you got to have toys, right?
That's exactly right. Perfect. Okay. So, you know, putting the energy back in, I think, clearly that explains at least a little bit about one of the advantages from an energy efficiency perspective. Any advantages to things like range as well? And I believe you guys have come out with is it the W56? Am I right on that?
The W56, our flagship product that came out last year. Yep.
Okay. So what are the advantages to that beyond we're putting some energy back into the battery, which is great because, like I say, you can't do that on an ICE vehicle. Are there other advantages that maybe people are missing?
So, how much was it the last time you had to do a brake job on your truck?
Oh, yeah.
Way too much money, right?
Yes.
And all they're going in and doing is they're replacing the parts that grip to put that drag on the wheel, right? Wear items. They get more and more expensive depending on your favorite brand. They're incredibly expensive these days, right? And the first thing that regenerative braking will do for you is it reduces the wear on those friction surfaces, on your traditional brakes like you have in your car. And who wouldn't rather go longer without doing a brake job?
Absolutely.
So there's an immediate kind of payback right there in that you have fewer parts that are wearing, or it's taken longer for them to wear out. So your rotors last longer, your pads last longer, and so on. Plus, if you think about the lost time of charging when you have to plug the truck in, if you can extend the amount of time between charges, capturing just a little bit of energy back on each brake, well, that's great too, because now your truck's not parked at a charger, you're not having to figure out where you're going to go take it to charge, and it allows you to deliver more packages or whatever you're doing with your truck in the same amount of time. So those are two big advantages. And then the third thing is when you do go to charge the truck, you still have to get that electricity from somewhere, a power plant or a solar panel or something. So you've reduced your cost to buy that electricity, no matter how cheap it is. You still have to buy less of it. And that's a cost saver right there.
Absolutely. And, clearly total cost of ownership is a big deal for anybody managing, if it's, one work truck or a fleet of 50, all that adds up. So I like that concept quite a bit. And you touched on it a minute ago. You said, in terms of parts, rotors, et cetera, extends the life of those. Are there studies around that, or is there a percentage of increase in terms of longevity that people might expect from a regenerative braking system versus traditional?
So it's interesting because it's really duty dependent, and you're never going to get rid of brakes. So everybody who's afraid that, hey, brakes are going to go away and we're going to be dependent just on a battery, that's not the case. You've still got to have that safety system in place. The parts are still there. For someone who drives a little bit more like a race car driver like me, I tend to go through brakes fast, right? And that's my duty cycle, right? That's how often I'm applying, how hard I'm applying, right? So it's a big benefit for me because I've retrained my driving in EVs where I almost never use the brake pedal anymore. So now I can go from a brake job in much too short amount of time to, going a couple of years at a time. For a truck, think about what happens in a delivery truck, right? When it's empty, the thing feels like it floats because it's built to carry a lot of weight, and so you're not really stopping heavily.
Right.
But think about maybe driving a truck with a trailer on it or a fully loaded work truck, if you're familiar with how that feels, right? You can tell you've got a refrigerator or a 10 behind you coming to a stop. You really have a lot of mass to stop, and that puts a lot of heat into the traditional brakes, a lot of work into those parts, a lot of wear on those parts. And the great thing about regenerative braking is the heavier the truck is, the more it can take advantage of that mass to recapture energy. A heavier truck can actually put more into the battery than an empty truck. So your duty cycle can really affect how much energy is recovered and how long or how much longer you can drive on a charge, whether it's the number of stops you're making or the weight in the vehicle. So it's hard to put like a hard and fast number on it and say, hey, everybody's going to get 20%.
Sure.
Some people may just use the traditional brake because they're not really confident in it and slam it on every time. They may not see any benefit at all. But people who can kind of learn to let the motor do the work can really see substantial savings. And pretty typically, we see 30% come back on a lot of the routes we do, particularly stop and go delivery. So that might take you from 150 miles to, I don't know. There's a lot of other things that consume energy. You might get 175 miles on a truck like that. But it's really duty cycle dependent and operator dependent.
Okay, and that makes sense. And probably like most people, I hadn't really thought about it from a, I guess, math equation perspective, but that makes a lot of sense. The heavier, the more you can take advantage of it. Wouldn't have considered that without you explaining it. So
yeah, I mean, it takes more juice to get a heavy truck moving.
Yep.
But the benefit is you get more back.
Right.
You're never going to get back as much as it takes to get it started.
Yeah, absolutely. And oh, sorry, Josh, go ahead.
No, I was going to say, Steve, I have one particularly enthusiastic demo driver around here. He claims that he sees numbers of 40 to 50%.
Wow.
I don't think that's real. I think he's a little optimistic there. But 30% is something we see pretty frequently.
Yeah, 30% still significant. Absolutely. Okay. And I think you touched on it at least somewhat. But let's talk about maybe the environmental benefits, not so much of an ICE versus EV vehicle, but more of the regenerative braking specifically and urban delivery type environment and so forth. What are some of the benefits you see there from a reducing emissions perspective?
Sure. So we already talked, the more deliveries you can do between charges, the more work you can get out of your truck without charging. You've got that benefit of not having to make the electricity to recharge the battery. So whatever the case is, fuel efficiency, whether it's an ICE vehicle or an EV, more fuel efficient, you're going to reduce any pollution you're creating there.
Yep.
One thing most people don't think about, have you ever noticed on the freeway all that dust and grime and stuff kicked up on the side of the road?
Of course.
And that's really coming from a couple of things. Maybe some of that's coming from diesel tailpipes, fine. A lot of that's coming from tires. As tires roll down the road, they spit off a lot of dust and dirt and chunks of rubber. And a lot of that's coming from the friction of traditional brakes clamping on rotors and kicking a lot of dirt and dust and metal shavings and stuff like that out. So if you think about it from that perspective, you don't have any friction in good regenerative braking, or you have less friction, and you're kicking off less dust and dirt inside a city or in a last mile delivery environment.
Makes sense. I think anybody that's ever looked at their tires or their wheels after driving a fair amount, you start to notice some of that brake dust. So yeah, 100% agree with that. Yeah, you bet.
All that brown stuff, that's all. When those tires get bald, that rubber is going somewhere. So
yeah, you bet. Okay. All right. So with any new tech or somebody trying to introduce a new solution, there's challenges, right? I think we all be foolish to say, oh no, it's easy. You just dive right in and here you go. So I'm curious, as Workhorse was going through the process of developing this type of system and so forth, what were some of the challenges you faced, as you were developing this product, if you will, or this solution, and how did you overcome them?
Sure. I've been actually developing regenerative braking systems for 25 years on various vehicles.
Okay.
And 25 years ago, batteries weren't very good, and we had to be really concerned about how much electricity we could recapture back in the batteries without hurting the batteries. Times have changed. Now we've got these great batteries. There's been a lot of development. We can recapture as much energy as we want, but it's not always a good idea to do that. People hear how regenerative braking works and they go, oh wow, we should really use this really strongly and really throw you forward in your seat when you're braking. And that's a cool idea, but it means that you lose dynamic control of the vehicle if you do it the wrong way. So Workhorse spent the better part of a year and a half really testing and tuning the system so we could get kind of the maximum bang for our buck, but not allow the vehicle to get into unsafe conditions or braking too hard or loss of control. And that means dry weather, and that means wet weather, and slippery roads, and cold weather, and hot weather, and with brake fade on the traditional brakes, and all these different factors that we had to account for to really test and tune that. And you see all your automakers and everyone else doing the same thing as they try to find that sweet spot of efficiency versus practicality.
You bet. I think like most things in life, overindulgence is typically not a good thing. It's more about finding the right balance for whatever it might be, and what you just described, I think, is a bit of that. It's find the right balance. Don't try and not necessarily over-engineer it, but overutilize it. Do what makes sense from a control perspective, with also that balance of the energy efficiency. So
one fun part of that, Steve, that we spent a lot of time working with that was kind of a challenge was to make the truck feel the same whether it was empty or full. Because when we put a fully loaded, the truck will hold 10,000 pounds and it only weighs about 13. So when you fully load a truck, you've almost, not quite, but you've almost doubled the weight of the truck.
Sure.
So it's a fun activity for the engineers to try and get you to have that same pedal feel, both accelerating and braking, regardless of what the truck's carrying.
Not an engineer, so when you say fun, I don't know that I would consider that a fun challenge, but I bet all the engineers out there went, oh yeah, that would be cool to try and solve that.
Involves a lot of pizzas and a lot of late nights.
Absolutely. Okay, so how about any good I guess real world or real life stories surrounding the W56 step van, and now that it's clearly you have it out there, it's certainly made its way into fleets and so forth. Any good stories to share with us?
Oh, there's lots of good stories. I mean, there's lots of great feedback. The thing we like, other than my test driver who claims he can get amazing numbers, the thing we like is that the truck just goes out and works. Our goal is that people don't even know or don't even care that it's an electric truck, because it just does what it's supposed to do day after day, the same way that any other truck would. And we feel like we're pretty strong in that camp. We love it when the truck goes away for 30 or 60 days and we don't hear anything, because it's just getting used. So,
well, I like the way you say that, right? It doesn't matter if it's an ICE vehicle, an EV. I've even heard people say, I don't care if it's powered by a watermelon, as long as it works, that's what's most important. Does it do the job I need it to do? That's really what I care about if I'm looking for a new truck or van for my fleet.
That's absolutely right. I'm not here. Workhorse isn't here. We're not all here to do science fair projects. We're here because we need to get people tools that they can use to do their job better than they did it last year.
You bet. Yeah, you bet. Absolutely agree. Okay. All right. So last question for you here, Josh. So just, anything you can share with us, what's on the horizon for Workhorse? Anything that you're working on that you can share a little bit, or, hey, this is coming. Folks might not know about it yet, but it's pretty exciting. Anything like that?
Sure. Well, this year we're really focused on getting the existing production truck. It's a great truck. It's really reliable. We're really focused on getting that into as many hands as possible. So that means we're doing things like releasing a longer wheelbase version here a little later this year. We're adding a lot of features and upfit content. We've got a lot of, we've put the vehicle out in a lot of fleets. And for example, we put it with a lot of linen fleets. Go out and collect linens and do daily deliveries to different work sites, right? Uniforms and so on.
Sure.
So we've learned a lot about kind of the special things they need. We've had a lot of luck recently, a lot of interest in a refrigerated unit where the refrigeration is done completely electrically instead of having an auxiliary reefer running. So we've been spending a lot of time developing production versions of that truck that are ready to go and can go out and serve refrigerated grocery fleets or other food transport or other medical goods, for example. So we're really working on, in the short term, expanding the portfolio of people that truck can serve and how it can serve it, different sizes of batteries and so on. Down the road, we'll probably look at adjacent markets for the truck and the powertrain, which we think we've really got tuned in well now.
Okay, makes sense. Expanding use case certainly seems like the right direction to go initially. So thanks for sharing that with us. And really, Josh, thanks for joining us today. Telling us a little more about Workhorse and some of the cool stuff you guys are doing. For anybody out there, if you've not heard of Workhorse before, hopefully this was a good introduction for you. Go check it out, see what they're all about, and maybe there's a vehicle that is a good fit for your use case and your needs. Josh, again, thanks so much for joining us today.
Thank you, Steve. And Steve, make sure to get yourself some toy trucks.
Shockingly, I have a couple of those here, as I mentioned, for our grandkids.
Thanks for your time, Steve.
Thank you, Josh.